Hello everyone. Today we'll talk about Amazon Web Services IoT Core, one of the best services that we have in Internet of Things field. And as you can see, Internet of Things is getting bigger and it's growing every day. So as together with that, we have a lot of services, we have a lot of tools, we have a lot of frameworks growing up to help us to establish to fast deploy and to fast develop IoT services and IoT applications in the cloud. So in the past it was very difficult to establish an application because we didn't have so much tools or so much, how can I say, so much frameworks that can handle the Internet of Things part and all the communications protocols. So now we have a lot of different services like Amazon Web Services especially the IoT Core, so we can fast develop a lot of things. And today we'll talk about using Amazon Web Services IoT Core with ASP8266, one of the most used microprocessors today for the Internet of Things field. And as I said, Internet of Things has been growing up, but we had a lot of IoT devices in the past. We had a lot of IoT technology in the past, but the difference was that it was very difficult to establish an IoT system in the past because you didn't have the cloud systems to help us. We had a lot of infrastructure problems and a lot of network problems. So now that we have the cloud systems and a lot of other services, it's very easy to establish connection between two devices. And I will show you today that we can easily connect two devices using ASP8266 and in your computer, and even you can connect another devices, a lot of ASP8266 together, or even in a mobile phone, and you can connect anything that you want with this simple example. So in this example today we will use the ASP8266 microcontroller, one of the favorites microcontrollers of the time, because it has a Wi-Fi shield where you can easily handle connections between the devices and between your local network. And as you can connect to your local network, you can have access to the cloud too. So this is a very simple example, but it can be extended to a lot of another examples, and you can do connections between a lot of other microcontrollers. So today, using the ASP8266, we will establish the connection with the Amazon Web Services. So using the MQTT protocol, one of the most used protocols in Internet of Things field. So we will make a communication with our broker, that is the Amazon Web Services, when we can publish or subscribe messages between the cloud. So as we are doing here, we are doing the connection between only one device, but you can do with a lot of devices. So you will have like a broker, and in this broker you can publish or subscribe different topics, so you can make communication between all the devices. So first of all, let's configure our environment in the cloud. So the first thing that you have to do, you have to go to the Amazon Web Services homepage. You have to have an account here to log on the Amazon Web Services console. So here we can see it. We just have to go to IoT Core here. Sorry, my page is in Portuguese. I will change here to the English version. Okay, now everything is good to go. So the first thing that we have to do here is to manage. Let's go to manage and things. We will create a thing here and register the thing. So just hit create a single thing. We will give that a name. It can be example class. We can create a type here, but in this example we will not create a type, and you can even create a group, but we don't need a group here. Here's it optional too. We don't need to searchable thing attributes here. As we have an example, we don't need on-click certificate or CSR or something like this. So create thing without certificate. Okay, Yes, okay. You have successfully created thing. Now, it, it it's very easy. You just have to point out some parameters that the Amazon Web Services will give to us here. So first of all, let's go to our things. Go to example class that we have created. Here we will have two things. First of all, we have to note this thing. This thing is your endpoint, is the endpoint of communication between the cloud and your device that we will have to put on the ASP8266. So we just have to note this first. So as you have already noted down the endpoint here, we will have to note this first MQTT top 2, the shadow update. So just note for using our example. And what's the shadow? As we can see here in the sidebar, we have the shadow, and the shadow is an topic that we can publish using the MQTT protocol. And if we publish it, and if our connection between the device and the cloud is successful, we will see that all the things that we published in the topic will be here. So we will use this later for testing our device communication. Now that we have already talked about the shadow, let's go. We will have to manage the authorization for accessing the cloud. So we will have to go to Identity Access Management, the IAM. So let's go here. We will go to Users, and we can note that in the IAM you don't have an availability zone. It's global. So I will add a new user here for an example. So it's ASP8266 example. I will put the auto-generated password because you will not need the password. So click next to put some permissions, and you can go to attach existing policies directly. So just type administration. Of course, this as an example, because this is not a usable good thing to do. We cannot attribute administrator access to every user that you create in an IAM. But as this is just an example, we can do that. So just go to next tags. We will not put end tags here. Next in reveal, okay, and create user. After we have created, we will see that we have an access key AZ2 here and a secret access key 2. So we will have to note down the access key and the secret access key, because we will use to establish the communication and doing the authorization part when you are establishing the communication with the cloud. So now I think everything is good in the Amazon side. So we will go to the Arduino to build the ASP8266 code. I have already one written here. So I will comment each steps of these codes. But first of all, we will have to have your Arduino IDE good to upload codes to the ASP8266. So first of all, we will have to go to File here and Preferences. And if you don't have this, we will have to put this Additionals Board Manager. We will have to put this URL here, because the Arduino IDE will detect that you can use the ASP8266 to upload the code. So if you just have it, just go to, after that we will have to go to Board and Boards Manager. And mine is already installed, but you just have to search for ASP8266 and just install the ASP8266 here. And after you have installed it, ASP8266, we will just have to go to board, and as a development kit of SP8266, I'm using the Node MCU development kit. So I will just have to select here the Node MCU here using the ASP module. And now let's go to the code. We have some dependencies here. In my article, I have all the links to download these dependencies. Some one of these dependencies are related to establish the connection with your Wi-Fi network, and other ones is from WebSockets to handle the web MQTT topics in WebSockets, the Amazon Web Services dependence. So, and one of the most important things that we have in the code here, it's some parameters that we will have to configure. So we will put here your Wi-Fi identification. So you will put your Wi-Fi identification here, the password, the Wi-Fi password, the endpoint that we have noted down from Amazon IoT Core, the one that we noted here, the AWS key, the key that when you created a user in IAN, the Amazon provided you, and the secret too. The AWS region, in my example, my region is, I'm using Ireland, so US 1. And the Amazon Web Services topic, the shadow topic that I have commented about, that you have noted too. So just put all the parameters here that we will go to the next part of the code. So after having inserted all the parameters here, we will have some variables defined here. So, and if you don't have the source code, I have uploaded the source code here in the article on the LinkedIn. So you have all the code here. You can get the code here. So, and getting back to the code in the Arduino IDE, we have this first function here, the generate client ID. That's a simple function only to generate an ID because this ID is required for make the connection with the Amazon Web Services. That's an important function here, the callback. The callback function, it will handle every topic that arrives with the MQTT message. So every MQTT message that arrives to our device, this callback will be called. So we have here our callback function. So every time that an MQTT topic arrives, this function will be called. So after this, we will have our connected method that we return true or false we dependent of the result of the connection. And here we will try to connect. We will have some serial prints to check on the console if everything is going okay. Here we will generate our client ID that is required for Amazon. Remember that our client is our AWS client, WebSocket client connection. We will try to set a server passing the AWS endpoint that Amazon have provided us and a port. And if everything goes okay, we return true or we will return false. After this, we will have the subscribe function. This function is very important because we will get the client and set the callback function that will handle all the MQTT topics. And we will subscribe the topic. Remember the topic about the shadow that we have noted down. Here we will subscribe this topic. And remember that you can subscribe any other topic that you want. It's like an HTTP endpoint. You can subscribe as many topics that you want. Here is just a serial print. Here is a function used to send a message. If you want to send a message to the MQTT topic that we have subscribed. And here are the two main functions of the Arduino code that everyone knows: the setup function and the loop function. The setup function is to do all the configuration and establish all the parameters that are important for the application to run. And the loop, it's our embedded loop that will run continuously. So we will enable the serial here. Here we will connect to our network. Remember that you have to put your Wi-Fi SSID and Wi-Fi password to connect to your Wi-Fi network. After that, it will check if with the Wi-Fi it's really connected, and if it is connected, we can go to the next part of the code. So we will set our region, the domain, the endpoint, the AWS key, and the secret that Identity Access Management have provided to us, and we'll call the connect function to try to connect and subscribe the MQTT broker from Amazon Web Services, and we'll try to send a message, right? So, and in the loop function is very simple. It will only check if the Amazon Web Services client is connected, and if it is connected, we'll only loop, waiting for MQTT messages, or if it's and here we will handle the reconnection with the Amazon Web Services. Now that everything is good, we will just have to upload the code to the ESP8266 to our device, and just pay attention to put the correct port, the USB port that you have inserted your ESP8266, and after that just hit upload. I have successfully uploaded the code, so we just have to serial monitor. I will just reset my ESP here and start to see if everything is going okay. Okay, it is trying to connect to my Wi-Fi network. Now it is connected to the Wi-Fi network, and it's trying to connect to Amazon Web Services. Wait a minute. Okay, that's connected, and MQTT is subscribed. And if we go to the Amazon IoT Core and go to our schedule, we will see that our schedule has already updated because we sent a topic here, right? So it's the desired on false reported on false. That's the same message that we put here on this function of send message. So we can see that we successfully established the connection between the Amazon Web Services and our ESP8266. So we can test a lot of other things here, and we can just change the Amazon Web Services topic here, because now we will test to send the topic to our device here. So I will upload the code again to change the Amazon Web Services topic. So now that we have already changed our Amazon Web Services topic, remember that it is a simple string. You can do as you like it here. You can change to anything here. And now we can go to the IoT Core console, go to test, and on this screen you can test and you can publish or subscribe topics to see if your device, so whether your device is connected to the Amazon Web Services. So I will put here the same topic that we have changed on our Arduino IDE, and I will try to publish here. And if I try to publish it, we can see that a message arrived, and if I try to publish again, we can see that our device has successfully connected with the Amazon Web Services. So everything now is working, and we can use, so our example is down, but you can use this example for a lot of things. For example, you can have a lot of different ESP8266 devices connected to this Amazon IoT Core. So we will have a lot of different devices receiving a lot of message at the same time, and you can even publish to a topic, and you can subscribe here in the IoT Core to see if your ESP is publishing in a topic. So that's okay, that's working now, and I hope you guys enjoyed the video. And if you have some doubt, or if you have something to add to this video or to add to this article, just call me. You can send me an email or in the LinkedIn. And thank you everyone.